Okay, let's use what we've learned about continuous functions so far to find where the following functions are continuous. Okay, so f of x is equal to 3x cubed plus 7x squared plus 1. It's a polynomial. Well, we already said that polynomials are continuous everywhere on their domain, right? If you think about graphing a polynomial, you know it's nice and smooth. And so this polynomial, the domain would be from negative infinity to infinity. So it's continuous from negative infinity to infinity. Okay. G here we have x squared minus 3x plus 2 over x minus 7. And this is a rational function. So it's a polynomial divided by a polynomial. And we know that both of those would be continuous. But what we have to be careful of here is where it's undefined. And we know that g of x is undefined at x equals 7, where the denominator is equal to 0. So we're continuous everywhere except for 7. Everywhere we're defined. So negative infinity up to 7, and from 7 to infinity. Okay, let's look at h of x. So h of x is equal to cosine of x squared. So x cosine composed with x squared. And here we can use our composition theorem. So cosine is a trig function. We know it's continuous on its domain, which is negative infinity to infinity. So cosine of x is continuous from negative infinity to infinity. And x squared is a polynomial, so it's continuous from negative infinity to infinity. So their composition must be continuous from negative infinity to infinity. D here we have another rational function. So again, we would look at where is it defined. In this one, if we factor the denominator, x minus 4, x plus 4, and even though it kind of looks like that x plus 4 should cancel out, you get a hole there. We can't just cancel it out and ignore it. So this will be continuous everywhere where it's defined. Well, it's not defined at negative 4 and positive 4. So we're continuous from negative infinity to negative 4, from negative 4 to 4, and from 4 to infinity. Okay, here we have two functions. So we have the square root of natural log of x plus 2. And two things. Well, for natural log of x, you can only plug in positive values. So we already know because of the natural log of x, we couldn't plug in anything that was less than 0. So at a maximum, we'll have from 0 to infinity. Now the other thing we need to check is that the whole radicand, natural log of x plus 2, is greater than 0. Well, that happens when natural log of x is greater than negative 2. Now, to solve that, we're going to take both sides. We're going to take e raised to both sides. So we would have when x is greater than 1 over e squared. Now, 1 over e squared is bigger than 0, so that kind of limits what we have. We'd be continuous from 1 over e squared up to infinity. Okay, and one last one here. We have tangent of x, and tangent of x is a trig function. So it's continuous everywhere on its domain, but remember tangent has all those asymptotes. So we need to remember kind of how we write that out. So we could say it's continuous everywhere on its domain. And the domain, remember, is all real numbers except, so one of our first asymptotes is that pi over 2, and then it happens every pi. So we say pi k, where k is any integer. So we have to leave those values out because of the asymptotes. But other than that, it's continuous. Okay, so when you're trying to decide where a function is continuous, look at it being one of these functions that you already know is continuous on its domain. And then either think about what its domain is, or because of composition, any restrictions that go on it.